Capital recovery of a project. This is a similar concept, something we have discussed before in the infinite analysis period. So the idea is you invest something today and how much you're going to need for each period to pay off that investment in a certain rate. In this example, typically you see in many government projects, like say the city is going to construct a bridge, or they're going to have some new water lines or electric line, gas lines. They usually last forever. And in the engineering economic analysis, we'll see that forever is about 30-20 years can be considered forever. Soon we'll see that. Now here is an example where it says that there is a bridge going to be constructed and there was this cash flow for the 8 years of that construction. So this is the amount the contractor spent for the 8 years. Let's say we get this loan from this contractor, and the condition is they're going to collect tolls forever at a rate of 15%, and how much money they will be allowed to collect per year as a toll to pay off all of their loan at 15% rate. So that's the condition. Now, so let's go ahead and solve this problem. Now there are a couple of ways we can solve this problem. I'm going to do it in the most logical way. Would be so these are the money that the contractor has spent for the last 8 years, and the condition is bridge will be open for use immediately starting of year 9. So by the end of year 9, how much money they're going to collect till end of year 10 and going forever, basically. And we'll see that it doesn't have to be forever. Basically 20-30 years is basically enough. You will see that forever doesn't have to be 1,000 years. It could be just simply 30 years could be forever. We'll see that concept soon. However, let me explain how we can solve this problem. So what we can do, basically, we can convert all of this cash flow at the end of year 8, so in the future, and then we can use that as a present value starting off year 9, 0, and then going forever, and then we can calculate per period cash flow, in this case per year cash flow, using that present value. Let me do it. It's going to make more sense when we basically work this problem. So period, as you know, in future worth analysis, we need to kind of reverse this whole thing. We need a reverse kind of period. So we're going to do this to create that reverse period, and then we'll type the future value here. So you can simply type that AV function, and then rate would be at 15%, and we're gonna freeze that because we'll be using that again and again, and then comma, it's gonna be for, let's say, next 30 years. We're going to freeze, well, no, number of year would be 8 in this case, because we are only converting this cash flow at the end of year 8, and then this year 1 cash flow, everything to going to end of year 8. So this $461,500,000, it will be compounded for 8 years. So that's going to be the number of compounding. There is no payment. We are just converting one single cash flow, the present value. We're going to keep the same sign. Probably doesn't matter, but we'll keep the same sign. And then like this. So this will be, then if we copy down, I would like to check the last one, if everything was copied right. Yeah, this interest rate was copied right. Now we can calculate the total future value basically for this bridge project. Basically sum all of these cash flows that was at the year 8. So basically if I convert all of these at the end of year 8, so that will be cash flow at the year 0. So the question was asking, the bridge is open immediately starting from year 9, and then how much money they have to collect per year forever to basically pay off this loan. So we're going to calculate use the payment function, but we can write PMT, payment function. So PMT, and then rate would be this, and then we can basically freeze that. Use this as a number of period. Soon we'll show you that anything over 20, this payment will not really change. And then we can use this, and then there is no future value. I think is 0. So about $1.6 billion per year they have to collect. Now if you change this value, let's say 1,000 or 100, doesn't really change. So I have created a chart here with that same. Basically what I did was basically use the different year, and then how much is the capital recovery. As you can see, after 20 is kind of flatten out. So in this case 20 years can be considered even an infinite amount of period. But if you change this number to 500, see, nothing really changed. 100, almost no change. 1.6, still 1.6. 30, almost 1.6, just a little bit more, but not a significant difference. So basically, to summarize, the government has to collect this much amount of toll per year to pay off this much loans they have taken from this contractor. And this is called the capital recovery. So investing something, and then how much you're going to get every period to basically pay off that investment. I think that's what I wanted to discuss.